Hi ladies and gentlemen, it's Mr. Green again. This is another in my recordings on Algebra 2. We're continuing on in Unit 4, and what we're looking at right now is system of linear inequalities. In this section, what we're going to do is we're going to determine whether an ordered pair is a solution to a set of linear inequalities, two variables, and we're also going to draw some graphs of system of linear inequalities in two variables. Okay? So looking at a system of linear inequalities, what we're looking at is more than one. That's what the word system would refer to. Linear means that they're going to be lines, so you're going to have more than one line crossing together. Since they're inequalities, what you're looking at are shaded areas. Now both of them are going to have shaded areas, and it's where the overlap of those two shaded areas is where the solution is going to be. So if the ordered pair is in that shaded area, then it would be considered a solution to the system of inequalities. So that's what we're looking for when we're doing these. So here they're asking us to first of all graph these two inequalities. Well, I'm going to quickly graph them. We're going to start with the first one. It says y is greater than 2x. So it goes through the point 0, 0, rises to run as 1. So it's going to be going like this. Okay? And it's going to be a dashed line going this direction, like that. And we're looking at, let's see here, which side of the line are we going to shade? Well, if we look at the point -1, comma 1 as one of the values there, then we can say that 1 is greater than -2. Well, that's true. So the side over here that has 1, -1 on it, that's the side I'm going to have to shade. And I got to get my little marker to stay up there for me. And let's pick a good color to shade this one with, and we'll pick a yellow color. And so we're going to be shading on this side of the line over here. Okay? Once again, our little 2-year-old comes out in us, and we can color well. Okay, now this other one, we have to try to graph it. Come on, pen. Thank you. It goes through the point -1. So there's right there. Okay? And it has a slope of -1/3. So that means we're going to go down 1/3. 3. Point there. Since this one is a solid line, I'm going to pick one of my line tools here. I'm going to start at one point and go through the other one. And start at one point and go through the other one the other way, so that I get them to look like a line. It looks like a line there. Now the question is, which side of that one are we going to shade? Once again, I'm going to pick the 0, 0 point for this one, since it's not on the line, and I'm going to get that 0 is less than or equal to 0 minus 1, so 0 is less than or equal to -1. Nope, that's false. So that means I got to shade the opposite side of where 0, 0 is. There. Got the tool selected, and I'm going to pick a color. Oh, let's pick green. And we're going to shade on this side of the line down here. And what we're looking at is the intersection of these two. So where is the area that I would be selecting to be my solution of this one? Well, it's going to be this area in here. The red area there. That's going to be where the solution is going to be. Anything in this area, any points that would be in this red area, would be considered a valid solution. Okay? Let's move forward. If we were looking at these two inequalities and we're trying to graph them, first one, I go up to 5. 1, 2, 3, 4, 5. And I've got a slope of -3. That means go down 3 and over 1, down 3, over 1. Okay? There are some points that are on that line. Since it's a less than or equal to, I could do it with a line tool and draw like this. Do it the other way. so that I get a nice little line that goes all the way across. Okay, now I'm going to stick the point 0, 0 in there. If I stick the point 0, 0 in, I get that 0 is greater than or equal to 0 plus 5, and that's false. So that means I need to shade on the other side of where 0, 0 is located, which means I'm shading over here. See how I'm picking what side to shade, right? Okay, so let's do the other line, the other inequality here. It goes through -1, that's going to be right here. It has a slope of -3. Guess what? That's the same slope, isn't it? So that means this line is going to be parallel to this other one. See how they're going to be parallel because it has a -3 slope as well? But we're looking at less than or equal to in this situation. So if I pick the point 0, 0 on this one and plug that in, I get 0 less than or equal to 0 minus 1, and 0 is less than or equal to -1. That's false. So I don't want the side that has 0, 0 on it. I want the other side. And so that's going to be everything over here. Guess what? These two don't intersect, do they? Since they don't intersect, there would be no solution. In case you didn't notice, we're always trying to give you an idea of what it looks like when you get no solution. Okay? Why? Because they're parallel lines. Well, that means they don't ever intersect, but this could cause the regions to intersect still, but since one of them is greater than and the other one is less than, you're probably not going to get any intersection between the two of them. So, no intersection, no solution. Okay, now we've got three lines that we're going to try to graph. Well, the one in here in the middle is actually the easiest because that says y is less than or equal to 2. That means all I got to do is go up to the point 2 to the y equal to 2 here and draw a line going straight across this way, and it's going to be everything below that line. Yeah, everything below that line. Okay? So we're looking at everything down here. Oops, got a little crazy with my yellow there. Okay, I think we got that pretty well identified. Okay, so the next one we're going to be looking at is the first equation there. And it says slope of 2 going through -4. So 1, 2, 3, 4. -4 is right there. And my slope is 2. That means we're going to go up 2 and over 1, up 2 and over 1, up 2 and over 1. Okay? And since it's a less than or equal to, it means it's going to be a dash line. I think we can just get by with this much of the line and not worry about too much more of it. If I stick a 0, 0 in here, 0 is less than 2 minus 4. 0 is less than 4, -4, and that is false, which means we need to shade the other side away from the 0, 0. Okay, so that's going to be over here. You see how I'm getting what I need to have shaded? Okay, next one, last one here. It's got 4/5 x minus 4. So I'm going to go down to -4. 1, 2, 3. Well, that's the same point, -4, isn't it? But my slope is 4/5. That means I go up 4. That means I go up 4. 1. Can't even count right. 1, 2, 3, 4, and over 5. 1, 2, 3, 4, 5. And since this is a greater than or equal to, it's a dashed line. Let's see if I can get a dash line. No dash line tool. Okay. So that means it's going to go something like this. Like that. Now, I'm going to stick 0, 0 in here again. I'm going to get 0 greater than 0 minus 4. 0 is greater than negative 4, and that's true. That means I need to shade the side that has 0, 0 on that one. Okay? Well, the side that has 0, 0 in that situation is going to be everything up here. And so you see what's the overlap between the two of them? And I'll pick that red color again to shade the overlap. It's going to be everything that's in here, in this little sliver like that. All those points would be in the solution set. Okay? Because it's on this side of the blue one, on this side of the green one, and on that side of the yellow one. So it's only going to go up to this point right there and be that little triangular area. That's all that it would be. It's that bright red triangular area there. Okay? So there's plenty of points in there that you could pick as in the solution set. Now, when we're given a graph like this and we're asked to find the system of linear equations that make it, first thing I'm going to do is I'm going to say, well, this one line that's a solid line, it goes through the point 2, so that's going to be y, and I'm going to have a 2 out here, and I know it's going to be either a less than or greater than or less than, and it looks like my slope goes up 1 and over 2, so that's going to be 1/2, and it's a positive, x plus 2, and so it's going to be y greater than or equal to 1/2. You can pick the point 0, 0 and stick it in here. 0 is greater than 0 plus 2. 0 is greater than 2. No, that's not right. It's got to be the other way around, doesn't it? Yeah, Mr. Green, you make mistakes. Here it goes. It's going to be less than or equal to. Okay? It's less than or equal to. So now we got to get this other one, and we're going to start with the y. It looks like it goes to the point 0, so there's nothing going to be added on. My slope looks like it goes, if I go up 1, 2, 3, 4, and I got to go backwards 1, so it's a negative 4x. And let's see here. Can't use 0, 0, but I can use 1, 1. If I stick 1, 1 in there, I get 1 is, well, I get 1, and I don't know what, I'm using the point 1, 1, sorry, write it down. I'm sticking a 1 in for the y, and I don't know what the symbol in between them is, and I've got negative 4, and I'm going to stick 1 in for x. So I got 1, how's that related to negative 4? Well, it's negative 4 is less than, so it's going to point that way. Okay? So that's my system of linear equations that I'm looking at right here. Now, having said all that, one of the ways they present problems of system of linear equations is in word problems, because you might have constraints that you're looking at, and you can solve problems using this. For example, if these two represented different constraints you might have in a particular operation, then you could see very easily one point you could pick would be this one here, or this one here, or this one here, or this one here. Those would all be valid points that would be solutions to your problems. A lot of times the intersection might be a good solution, but since it's not a valid point, you can't use that intersection, but you might be able to use this to 0 or 0, 2 as one of the valid points that you might want to consider. Okay? Having said that, don't forget that if you're sending me a K-mail or instant message or anything, make certain you include the course name on it so that I can find your records really quickly. I appreciate you listening, and I'll see you next time.